All right, guys, welcome to today's class. Today, we're going to continue where we left off and do review problems, all right? So let's start with the 124. In each of the diagrams below, name all pairs of the congruent triangles you can identify without drawing more segments or naming more points, all right? And why are these congruent? You got to explain. Well, this one's obviously congruent just because by SSS, all right? It should come quicker the more you practice with these congruence postulates. But it's okay if it's first slow, but it's gonna become way faster once you've done more of these questions like this. Alright? So this one's pretty obvious. ABC is congruent to BCD, not in the particular order. Right? And for this one, semi that we don't well, let me see. Is there anything we can derive from this? Well, there is none because it's not possible. Because why is because it's ASX. And we don't know if these are the same. Obviously they look the same, but these are not the same. We cannot possibly prove that. Right? Now for JLK and LMN. JLK and MN. Well, this is pretty obvious that it's true by AAS or ASA because this is a parallel line. So this angle is equal to that angle, and this angle is equal to that angle. And this one. These are angles of the same. All right. Now for this question. Well, are they the same? Well, we know that this side is the same. All right. These sides are the same. So we can prove by AAS that this is true, right? Which is BF is equal to CE and A is equal to D and B is equal to E. Well, this one's also AAS slash ASA. Well, you can also do ASA on this question because you know two angles, you will always get another third. Now, GHJ and HIJ. Are they equal? Well, yes, by SSS. What? Hold up. Hmm. Oh, yeah, these are equal because by SAS. We can prove it by SAS. You can prove it by SAS or some other thing, because this is a little. These are parallel, right? Wait, hold up. Well, this is not parallel. Okay. So you have these two sides are equal, right? And we have these parallel lines. So this is the transversal. So this angle is equal to that angle, and this angle is equal to that angle. Same thing. And we have this angle, which is also equal to. Let's see. We only know that this angle is equal to that angle because these are parallel. What else can we derive from this? Well, we can know this angle is equal to that angle, which is also equal to this angle. Alright? Let's see. Oh, we don't know that these are parallel. Hold up. My fault. My fault. We don't know that these are parallel, so I'm sorry. We only know these are parallel. So we only know that these two angles are the same. Is that more than enough? Well, this just gives ASS, which is clearly not true. We cannot. It's basically not possible. So we had to skip this because it's just not possible. By SSA is not a valid congruence postulate. Now let's go to F. F, it's pretty obvious by SSS. Alright. G, well, we want to, this looks like AAS, and it is indeed AAS, because this is a vertical angle, and you got these angle and the side the same. So from AAS, this is true. Alright. These are basically the same exact flavor. So I'm going to skip the last two and move on to the next question. 3.25. Find the vertex angle of an isosceles triangle if one base angle is 6 degrees less than half the vertex angle. Right? We have two base angles and one vertex angle. And we know that one base angle is 6 degrees less than half the vertex angle. Say the vertex angle is x, then it's just going to be 1/2 x minus 6. And we have two of these plus x, which should be equal to 180. Solving this equation, just gives 2x minus 12 equals 180 or 96 as your answer. 96 degrees for the vertex. All right. Now find x. Now for 3.26, find x in the diagram shown below. I'll just have a try on this question and tell me answer to chat. All right, let's get started with this question now. So find x in the diagram below. We have this is x and this is 2x, all right? What can we come from here? Is there any possibly useful information? Is there any useful information can we get from this? So we can try using parallel lines, all right? Notice how this is a transversal, right? This is 3x, right? This is 180 minus 3x, which is going to be equal to that. So both of these are 180 minus 3x, all right? Adding this all up gives you 360 minus 6x plus x, or 5x, or 180 equal to 5x, or x is 36, right? If we have a bunch of x's and we don't have any angles, we want to try to make it so that we get an angle measurement. Yeah, that is indeed correct. P is equal to x and C equals B. Yup, that is indeed correct, right? Anyways, let's move on to 3.27. Find A in the diagram below. All together, have a try this question and tell me answer to chat. All right, let's get started with this question. Clearly, this is an equilateral triangle. We want to make use of any angles we see here. This is an equilateral triangle. This is 60 degrees. This is also 16. And this is also 60. Since this is a supplementary angle to CVD, this is 120, which results in this is 30 and this is also 30. Or the final angle, or 30 degrees. Right? Now let's do 3.28. Segments AB and CD meet at point P such that AP is equal to CP and BP is equal to DP. Is that always true? APD is congruent to CPB, and is it always true AD is parallel to BC? Let's use time for trying this question and tell me through chat. All right, let's get started with this question. Is it always true APDs congruent to CPP? Right, let's see. AB and CD media point B. That's the AP is equal to CP and BP is equal to DP. Is it always true? Yes, because by SAS this is true. Is it always true that AD is parallel to BC? Not necessarily. Not necessarily. We can have it, we can have the same angles and everything, but we can't just get it to intersect at one time. So that's clearly not true. No. Now let's move on to 3.29. Let PQR be a triangle as shown as the right, and let S and T be points on sides PQ, PR, and QR, respectively. Triangle PTS, PTQ, and RTS are congruent. Show that PST is equal to 90 degrees by the measurement of angles of PQR. I'll let you know for trying this question and tell me to chat. All right, let's get started with this question. So PER is a triangle as shown on the right. And S and T are going to be points on the sides PR and QR, and then PTS and PTQ and RGS are congruent. Show that PST is 90 degrees. Quite obvious because PTQ is equal to PTS, so this follows. Find the measurement of angles PQR. Well, what can we say? Well, these two angles are congruent, and this one angle is also congruent. So let's be 3x is equal to 90 degrees, since this is already a 90-degree angle, or x is 30. So this is pretty much a 30, 60, 90, okay? 90 triangle. Alright. Now let's move to 3.30. In triangle NOK, KO is equal to KN. Find that AI be the point on KN such that OI is equal to ON. Let A be the point on NO such that IA is equal to IN. Find the three angles in the diagram equal in measure to N. I'll try this question and tell me your chat. Well, let's get started with this question. So find the three angles equal to measure to n. So n, well, it's gonna be equal to n, and we also know OI is equal to ON. So it means that NIO is also equal to n. And we have IA is equal to IN. So what can we use from here? Hmm. We also know KO is equal to KN. Interesting. Since KO is equal to KN, then this just means that KNO is equal to KON, right? And we need one more angle to complete it. Now notice that over here we also have an isosceles triangle. So we also have an AI is also congruent to N. All right. And finally, and prove that IA is parallel to KO. That's pretty simple. Since this angle is equal to that angle, that means this is a transversal on parallel lines. And then boom, problem solved. All right. Let's move on to 3.31. In diagram below, O is the center of the circle. OA is equal to CD and OAB is equal to OCD. Show that BOA is congruent to OCD, then prove that OC is parallel to AB. I'll let you have a try this question and tell me to chat. Let's get started with this question now. So diagram O, we have OA is equal to CD, yep. And then AOB is equal to OCD. Now we want to show that BOA is equal to OCD. We have the angles are the same. We want to also use the fact that all radii are the same. OA is equal to CD, and we know that OC is equal to OB. Alright? And we're also given that AOB is equal to OCD. Therefore, by SAS, this follows, right? Always use the fact that all radii of a circle are the same length. Now we want to prove that OC is parallel to AB. How does that come into mind? We notice that this angle, we have OCD. We notice that, well, it's kind of confusing at first glance, but we can notice that this angle is equal to that angle. Since it says for B, it's going to be equal to O. Since it's this, they correspond. O is equal to C. That is D, and then A is equal to D. Corresponding, right? Now, since the O in this case over here is equal to B, what can we get from here? Well, we also want to see if it's parallel, which means that these are the equal. Well, oh wait. We don't know if this is straight, alright? But we want to prove that OC is parallel to AB, alright? What comes first into mind? Alright. Well, notice that ODC equal to COD. And why is that true? Why is this true? Well, because oops, I should have realized this before. It's because it's radii, alright? These are all radii. So these are all equal. So which means it's an isosceles triangle. And then boom. It comes that these two angles are the same. ODOC is equal to OAB. And then the result follows. Since they're all radii and radii are equal, these are isosceles triangles. These angles are the same, which follows, alright? Now I want to show that OCB is equal to 2OBA, right? OCB is equal to 2OBA. How do we approach this part? Well, we can try to use arcs, alright? Did we cover arcs before? No, we didn't. We didn't talk about arcs, alright? Let's clear this diagram up. Let's just say it's SAS. And we're going to, well, that OCB is equal to OBA. How does that come to mind? Well, notice that this angle is equal to 180 minus OAB. It will be, let's say, let that be X. It's 180 minus 2X. This is X. This should equal to 80, so this should be X. Alright. Since DOC is also X. Alright. Now, what is OCB? Alright. We know that OCB is T2OBA. How does that come to mind? This. Since these two are X, this just means this is 180 minus 2X. But then OCB is just 180 minus OCD, or which is equal to 2X. You have 180 minus that, or 2X. Now we want to find OBA. This is pretty simple since we're already solving. And this is an isosceles triangle, by the way. This is an isosceles triangle, by the way. Done. This is an isosceles triangle, which is telling you that the base angle. What's the base angle? Well, the base angle is equal to 180 minus x divided by 2. So we know that 180 minus x divided by 2 is equal to 2x from the previous one, which results in 4x is equal to 180 minus x, x is equal to 36. Or answer is 36 degrees. Alright. To prove this, you just gotta use all radii are equal and the amount of isosceles triangles. Right? Also, angle chase also. Now that, let's move on to 3.32. In the diagram below, AD is going to be B. Alright? And is also equal to AE. Alright? All right, so AD is equal to BD is equal to AE. And DE is equal to EC. Prove that AC is equal to BE. Well, how do we go through this? Well, notice that there's a bunch of isosceles triangles going all over the place, all right? A bunch of isosceles. So, what can we use it from here? Well, we want to show that AC is equal to BE. First thing that comes up to mind that pops out is congruent triangles. We want to find a congruent triangle. Preferably, AEC is congruent to BDE. Preferably, it's that. Because these look very, very similar. How do we prove this? The only stuff we gotta do is either show AC is the BE already, which you can't right now, or show that one of BDE is equal to AEC. Because the first thing that pops up is SAS. Right? Now, how do we go on to solve this? Well, this is pretty obvious from here. Once we figured out our goal, we would know where to start. First, we want to show that these are equal, right? But then how do we do that? Well, this is pretty simple. Since we can see there's an isosceles triangle over there. Now, since this is an isosceles triangle, we know that this angle is equal to that angle, which means that in return, AEC equals BDE, alright? Since isosceles triangles have equal base angles. Now from here, we can derive from here that AEC is equal to BDE, which implies that by SAS, BDE is equal to AEC, which results in AC is equal to BE. And then we're done. Alright? So we just use congruency relationships and angle tracing to solve this question. Alright? So that's it for today's class. I hope you guys have a wonderful weekend. I'll see you next week. Bye.